Following on from the previous video, we were trying to derive the formula for the surface area of a sphere, and we got to this stage here. We got to this stage here where the surface area for half of a sphere is given by this thing here, and then right at the end we're going to times it by 2. Then that will then give us the whole thing. So from 0 to r, we are really summing up everything here. Okay, so we're moving in the x direction. So we start with dx, and then this bit here will then give us the arc length. Once we've got the arc length, we will need to times it with the circumference of a circle. And this y here, this y here is really the height of the strip as we're moving along in the x direction. So we are moving along in the x direction from 0 to r, from 0 to r. As we're moving along here, the height of each strip is always changing. It's always changing, and this y here is the height. So we will need to know the height as we move along in the x direction. Okay, but we can easily obtain the height by looking at this. This is the height as we're moving along in the x direction. Just bear that in mind. Well, anyway, to find this surface area, we would need to evaluate this. Now, looking at the formula here, we would need to know dy by dx, and then later on we need to square it. So from our equation of a circle, rearrange it. Let's just rearrange it. You would get this. Rearrange it, you would get this. But let's just concentrate on the positive version. Ignore the negative. So y equals this thing. Let's reimagine this as this. If you look at the formula, this is what we're trying to work out. But looking at the formula, we would need to know dy by dx. So from here, we're going to try and work out dy by dx. So imagine this as this, and then differentiate it. It will then give you this, and then so now we've got dy by dx. Now, if you go back and look at the original thing here, we've got dy by dx, but now we need to square it. So we've got dy by dx. We now need to square it. So we've got dy by dx. So now we square it. So that will then give us this. Okay. So now if you look at this, we now know this whole thing here. This thing here is this bit here. So we can put that into there. Okay. So that will then give us this. So this thing here will be this. And earlier we said y is really the height of each strip as we're moving along in the x direction. Well, y, if you rearrange it, y is this thing here. So basically, this is really the height of each strip as we're moving along in the x direction. And then this thing here is this thing here. Okay. So now just tidy up everything. Imagine the 1 as this. This is 1 because exactly the same divided by exactly the same, so must equal 1. This is exactly the same as this. Same denominator, so you can merge the two fractions. So that will then give you this. Okay, that will then give you this. So now from here you can you can do this because root a over b, that's the same as root a over root b. So you can jump in, and then this block here is exactly the same as this. So they will cancel each other out. This is just r. So this whole thing here would then become this. Now this is easy to integrate because you're integrating with respect to x, and pi is a constant. Radius of that circle is a constant. So this is a constant, this is a constant, therefore the whole lot is a constant. So when you integrate it with respect to x, it's just basically a constant times x. It's like me asking you to integrate 3. Well, integrate 3, you're gonna get that. So this is a constant here. So when you integrate it, you get this. Now it's a matter of doing this and then take away this. So that will then give us this, and then overall remember the integral was from 0 to r. So it was from 0 to r. So this whole thing here only represents half of the sphere. Okay, so really what's going on here is that we are summing up everything from 0 to r. If you look at, let's look at this. So we are summing up everything from 0 to r. Let's look at this one particular strip, dx here. The thickness associated with this strip is dx. So we've got our dx. We worked out the arc length. Once we've got the arc length, then we revolve it around 360 around the x-axis, and then summing up everything would then give us this. So this thing here represents half of the sphere. So now the whole sphere would then, well, times it by 2. So that would then give us this. Okay.